We're all familiar with brick. Brick is a great exterior product. Most people don't understand that modern day brick is a siding material. It has an air gap between the house. Brick is not impervious and can be subject to damage. Damage can be in the form of settling or heaving. If you're familiar with these cracks, then you know that bricks can tell their own story. The series of cracks in the brick can actually point to its own defect if you follow it down to its loading point. Here is a crack, and if we follow it down, it actually points to this metal window lintel. What's happening is the lintel is deflecting and can't quite carry the load. Part of the reason is because this is not like modern brick, which is cast with holes. This is solid brick, which is a lot heavier. The lintel is transferring its load to the edges, which transfers down to the actual foundation and into the basement. Now that we established a crack in the foundation, here's another example of cracked bricks that are pointing to their instigators. There are two cracks on the right side of this building, and they both point to the same direction. I followed them down to the foundation, to the ground, and over to this. I wasn't sure what it was at first, but it's a tree stump. What happened is this tree had blown down in a storm, so they cut it down. Problem is now the tree is rotting, so what was once a heaving crack is now a settling crack as the root system rots away. Also, you can study these cracks to determine if they are fast or slow moving cracks. This is a slow moving crack based on its pattern. Slow movement will take the path of the mortar, while a quicker settlement takes the quicker course straight through the brick. You also need to come up with a separation number that you consider to be a structural issue. The industry considers 1/4 of 1 inch to be a red flag. Now that means a settling crack in the foundation or brick is 1/4 of an inch or displays characteristics like shear movement or bilateral movement, etc. I have extended my number to 3/8 of 1 inch. I figured once a crack exceeds the industry standard by 1/8 of an inch, I'm well within my rights to call a foundation company or a structural engineer. Also, visually looking down the course can be a good way to determine if settling has occurred, but keep in mind, masons use masonry string when setting courses, and even at a high tension, the tightest masonry string will have a bit of a dip. Here's another example of a foundation wall crack pointing to its nemesis. In this case, it was a basement and had water issues at this corner, which was compounded by a nearby sycamore tree. In this case, the first attempt was mend or anchor plates to keep the foundation from pushing out any further. Once the plates started to move a little bit, they installed this metal channel vertically, which helps keep the foundation wall plumb. Channel basically causes the wall to act as a hole. Then added adjustable supports to help with the floor joist deflection, and once they established this and determined that they had stopped movement, they did epoxy injection, which basically just drilling holes in the cracks and inserting these injection ports and injecting the epoxy. The epoxy fills the voids. Now in this case, 3 injections were needed because usually the first injection is a cursory repair. Then you wait till a heavy rain and see if you've stopped water entry. Sometimes the epoxy injection can actually push a leak to another location, and then through warranty the company can make multiple trips using the same ports. Even the worst foundation issues can be repaired. It just depends on how much you want to spend. Want to know what else I saw today? Subscribe to our channel and we'll keep you in the loop.